songs are good.
Okay, today we're just going to do practice with solving differential equations. So we're going to spend 2 days just to kind of get really comfortable with this or with this topic. I'm going to skip 15 for now. These were I want to kind of get more comfortable with X and Y variable before we look at the other variables. I mean, it's not too bad, but it's just, I think it's nice if we just kind of do some things that we're more familiar with before we get to page 15. So let's start with 16, and then we'll make our way back to page 15. All right, so so first things first, we want to, it says, let's see, y prime is equal y prime minus xy cosine x squared equals 0. Given y of 0 equals 0, find the general solution, find the particular solution. So we're going to have to solve for y, we're going to solve for c. But let's start off with our initial step, which is rewriting the equation, right? So y prime, we can rewrite as what? dy dx. And then we want to begin to get our fraction equaling each other so that we can cross multiply, right? So working towards cross multiplying so that we can get our equation to be lined up the way that we want. So I'm going to bring this whole term to the right side. All right, good so far. Okay, so fraction equaling a fraction, we can cross multiply. Cross multiplying will not guarantee you separation of variables, but it will get some things lined up. You will get your dy and dx's lined up at the very least. So I want us to recognize that we do have some things in place for sure. dx and dy's are in their right places. We're not going to move them. If we're moving anything, we're moving things around it, but we don't want to move these after this step. All right. Now we have to ask ourselves, do we have full separation of variables? Are the x's all together on one side? Are the y's all together on the other side? No, there's one thing out of place. What's that? Y. Okay, so what do we do with the y? Divide it, it's going to end up where? Denominator. Okay, so don't be afraid to have variables in the denominator. We have rules for that. I see some students, they want to put the y in the numerator because it feels more familiar, but then the algebra is not going to be right. So, so if it ends up in the denominator, then that's where it is. I mean, it could end up in the numerator, but your algebra steps should tell you where the variable ends up. So let's see. Okay, so now do we have full separation of variables? Yes. Okay, so now we're ready for our calculus step. All right, left side, we got a, what's the rule here? Yeah, natural log absolute value of y. But the right side requires a little bit of what? Well, chain rules for derivatives. What's the integral version of chain rule? Use substitution, right? Use substitution. So we have to keep in mind that, you know, not both sides aren't, you know, one may take a lot longer than the other side. So one side may just be a quick integral rule. The other side, we may have to go through a little bit more. So just have to keep that in mind, right? We don't want to assume that both sides are going to be quick and easy to find the integral. Sometimes we got to take the additional step to. So this, from the previous unit, this will be a standalone problem, right? But now this is part of a larger problem that we were working on. Okay, so what's our u value then? Yeah, cosine x squared is a little bit too much, because if cosine of x squared is the u value, the derivative will be negative sine of x squared times 2x, and we don't have anything that's going to pair up with that, right? So it's a little too much. A better u value could be what? The x squared, right? So whenever we have a guess for the u value, think about the derivative, right? And if you can think about the derivative, and if the derivative shows up elsewhere in the problem, then you know that you're on the right track. But if your derivative doesn't show up elsewhere, or if you don't see a match with the remaining x's, then it's probably too much. Right. So our u value is x squared, so we're going to take our time to build this out here. So u equals x squared. Derivative is 2x, okay? Cross multiply. Dx equals du over 2x. Okay, we make our substitutions. All right, what happens here? Yeah, x is canceled, but there's what left over? 1/2 in front, right? Okay, we're ready for our antiderivative step. Cosine becomes sine, positive sine. And then we can bring back what? The x. So the left side was quick and easy. The right side, we got to go through all this. But now we can set them equal to each other. Any questions so far? Now they are asking for the general solution first. So we're just going to take our time and, well, we're just going to solve for y first. And then after we solve for y, then we can solve for c, since they are asking for the general solution. So let me reset and put this at the top of the page. Okay, but the calculus is done. Now it's just a matter of cleaning up, and ultimately we're going to have to solve for y, and then we'll have to solve for c as well. Okay, so we're focusing on building the general solution. So we want a solution where we solve for y, but the c is left in our answer. Okay, so then we're going to work towards solving for y. What can we do to both sides to undo that natural log? AC cancels out. Okay, so now our goal here is to try to separate the c away from the variables, and we have a special property to help us with that. A to the m plus n is equal to a to the m times a to the n. So I have e to the 1/2 sine x squared. What? What's the operation? Times. Okay. Right, times e to the c. And then we know e to the c is just one. It's just one big constant c that's being multiplied, and we can push that in front. We can drop the absolute value. The c will absorb the plus or minus from the absolute value. Okay, we have the equation solved for y. We have c cleaned up So this is part A. This is our general solution. All right, any questions so far?
Yeah, it's like I don't know if it's a permanent thing, but like I realize C becomes like kind of like capitalized a little bit as you go through the.
Yeah, that's right. I mean, it's the same as this C right here. It's just that if I have e to the C, I'm just representing that as a base C rather than exponent C. But I mean, if you did lowercase c, that's fine as well. It's just typically we use uppercase C. All right, so now part B is finding a particular solution. So that means we have to solve for what? We want to find a way to replace what? The C, right? So we want to take the order pair, 0 in for x, e in for y, and then algebraically we'll solve for C. Once we solve for C, then we can replace that with the number that we find. Okay, so we're going to work on this general equations to see if we can update it. All right, so 0 will go in for x and e will go in for y. Okay, so what do you know about this here? What's sine of 0? Sine of 0 is just 0, right? So if we look at our unit circle, right? This is 0 degree here. And then the order pair is 1, 0. Sine is the y value. So sine of 0 is 0. So if that's 0, 0 times 1/2 is still 0. E to the 0 is 1. So that's going to wipe it out. But it's not going to wipe the whole thing out. We still have the C left over. So C is simply just E. That's my C value. E is a number that we can put in for this here. So now I'm going to update my equation now. So it's going to be E times E to the 1/2 sine x squared. Okay, you can leave it like this. But I do want to show you, if this was a multiple choice question, they would try to clean this up a little bit more. And what they would do is they would put it back as one base, because we know that a to the m plus n is equal to a to the m times a to the n, but we can always go backwards here. We can always take this and bring it back to the sum of two exponents. So you could also see the answer written like this, e to the 1 plus. Now, if it's free response, they will take both solutions, but I just want to show you what a multiple choice solution could look like. You know, if you're at this stage that you can make the jump from here to here and select something that is in that form.
That's particular solution, is that?
This is the specific solution. Yeah, this is the particular solution because the C has been replaced with a number.
Okay.
Okay, page 17. Okay, so first things first, we're gonna replace that y prime with dy dx. We're gonna try to, after that, we're gonna try to get two fractions to show up so that we can kind of work towards cross multiplying. Okay, let me get two fractions lined up here. I'll add this term to the right side and set everything up as numerator over denominator. Okay, everybody good so far? Okay, next step, cross multiply. Still looks messy, I know, but at least we have some things set in place. Now we have to ask ourselves, okay, do we see full separation? Are the x's together on the same side and are the y's together on the other side? There's two things out of place. What's one thing that you notice? Yeah, the x, right? The x is in the wrong spot here. So we got to do what with the x? Divides. So where's going to end up? Denominator. Okay, so we'll keep that in. We'll just keep that in our heads. What else needs to move? The y. The y also has to do what? Divide over, ends up where? Denominator. So both the x and y are going to end up dividing on to both sides. Let's just do one operation and just make that happen at once. But both the x and y are going to end up in the denominator on the other side. Right, so let's see what that looks like. Are we okay with that double operation there where we're dividing the variables to the other side? Okay, so now do we have full separation? Y's together, x together. Okay, so now integral here. Now, I do want to talk about something here. This is natural log of x to the fourth. Is there another way to write this? Maybe a little bit easier to we can do what? Well, quotient rule is for derivatives, but I'm just talking about is there a property that 4 can do what? Can be in front, right? We have a log property that says if I have natural log of a to the n, I can bring that natural log, I can bring that exponent down. It just makes it easier to work with when that exponent is kind of out of the way. So let me rewrite that. It feels like it's a little bit cleaner there to potentially recognize what we need to do on the right side. Okay, but the left side is easy. 1 over y dy is what? Natural log absolute value of y. Okay. I feel like sometimes students expect both sides to move quickly, and so they end up skipping some important steps because they're trying to do this in one step, and sometimes a problem requires more than one step. So in this case, can we tell what needs to happen on the right side? There's what going on here? There's u substitution. Okay. What's our u value, you think? It's gonna be natural log of x, because the x can't cancel natural log of x, but natural log of x can cancel the x, because what's the derivative of natural log of x? Yeah, u prime over u, 1 over x. So we see a derivative that is going to pair up. So anytime you select a u value, think about the derivative. You see the derivative pairing up with the leftover x that we didn't assign.
You leave 4 out of it.
I'm sorry?
You leave the 4 out of it.
Yeah, leave the 4 out of it. The 4 can just hang out in front. It doesn't have to be, anytime I see a coefficient, it's usually not part of my u value. Okay, so let's go through our full process here. Left side, right side is going to take a little bit longer to get through. Okay, like we said, u prime over u, natural log of x becomes 1 over x. Okay, cross multiply. Are we good with the substitution so far? The natural log of x is replaced with u. The dx becomes x du. What's nice here? X is canceled out. That's what we want, right? We need the x to cancel out through u substitution. So now we're just left with the integral of 4u. What rule can we handle with 4u du? Our rule, yeah. 4u becomes
4u squared over 2.
Plus c. The 4 and 2 can reduce. I can bring back what into the problem? Yep, the x replacement that we made initially. So u equals natural log of x. Natural log of x, quantity squared, plus c. And then the left side we can bring back down again. Okay, so the calculus is done. Any questions here? Now, can I bring this 2 down in front? No. Again, this is a different thing than this property. Okay, if my exponent is just within my term inside natural log, I can bring it down. But if my exponent is covering the entire expression, then there's no property for us to bring down. We have to leave that alone. Okay, so let me reset because now it's the cleanup stage, right? Okay, so we're not asked to find the specific solution, just a general solution, because no order pair was provided for us. We just have to solve for y. So what can we do? Both sides do what? AC. Left side cleans up. We can separate the c away from the expression by multiplying and making it 2 bases. E to the 2 natural log of x quantity squared times e to the c. We know e to the c becomes just c. Pull that in front, drop the absolute value, the plus or minus gets absorbed into the c. So here's our general equation. That's all we can do. No order pair, so we can't go any further than we can't solve for c if the information is not provided.
How were you able to drop the absolute value?
Right, the absolute value was dropped because so technically when we drop the absolute value, a plus or minus is going to show up. But then c already represents both positive and negative numbers, so the plus or minus can just get sucked into that c. Okay, any questions here? Okay, I do want to make sure I get through 15 because we've only been dealing with x and y variables, and we do have to be comfortable with variables that are not x and y. So now that we have the foundation set, let's see if we can tackle some problems that are not x and y. So let's go to page 15. So page 15, let me read the problem here. The rate at which baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams, then db over dt equals 1/5, 100 minus b. Let y equals b of t be the solution to the differential equation with the initial condition b of 0 equals 20. Use separation of variables to find y equals b of t. The particular solution to the differential equation with initial condition b of 0 equals 20. So we're gonna separate the variables and go through the whole process. It's just that it feels more difficult potentially because we're not used to the variables that's in front of us. But one thing I want to clarify is that I know we're used to x and y, okay? But if you have a word problem, it's always going to be done this way. It's always going to be time with some other random variable. Right. So your t, if you see t show up, t is your x. Okay, so we just have to kind of get used to the idea that, okay, instead of x, it's going to be t. And then whatever other variable that we see, it could be w, it could be z, it could be m, it could be n. In this case, it's b. And your other strange variable, that's your y. Right? So we have to kind of just get used to that kind of get used to the idea that, okay, if I don't see x and y, it's always going to be time and something else. T is now your x, and then in this case, b is now our y. Okay. So let's start with our differential equation. And I'm going to force this into a fraction just like before. And again, we talked about how we don't want to lose the set of parentheses at the beginning, right? The whole idea is that parentheses is there to help us with our separation. Once we have everything separated, then sure, you can drop the parentheses, but not before that. So I'm going to force it into a fraction so that I can begin my cross multiplying step. Everybody okay with rewriting it into something that we can move into cross product? So now we can do cross multiplying. Okay. Instead of x's on the left and y's on the, sorry, instead of x's on the right and y's on the left, now we want b's on the right and b's on the left and t's on the right. So we have this here. Okay, so just like before, instead of dy and dx's lined up, now we have db and dt lined up. These are your anchors, right? We're not going to move them. We're not going to touch them. If anything, we're only moving things around it. All right, do we see full separation of variables? Do we have t's on the right and b's on the left? And what's out of place? Yeah, the b is out of place. So we have to do what with this 100 minus b? Divide. It's going to end up in the denominator. Okay. Now, before we do that, I do want to point something out here is that this 5 does not have to be on the left side. Okay, and then the way I like to do things is if anything doesn't belong on the left side, I'm going to go ahead and move into the right just because it'll just save time down the road. Right, so it's not wrong if you leave that 5 on the left. But anything, I just would like to keep that left side as minimal as possible because eventually we have to solve for b, and the less that we have there, the less clutter that we have on the left side. So I'm going to move the 5 as well. If I want to move the 5, where's it going to end up? Also denominator. So they're both going to swap places. And they're both going to end up in the denominator on the other side. Okay, now that we have full separation. Okay, so we're ready for our calculus step. What do you think we have to do on the left side here? U substitution. Okay, what's our u value? 100 minus b, entire denominator. If maybe I can rewrite it in a form that feels more familiar if I write it this way. And then, okay, so I'm going to do that on the left side. On the right side, what will make this a little bit easier for my calculus step? That 5 is the same thing as what in front, as 1/5, right? And technically there's a 1 here, if it helps. We're taking the integral of 1 dt. Okay, so left side, we said use substitution there. So we got to go through the whole use substitution step. Instead of du over dx, now it's du over db. Or sorry, instead of dy over dx, du over db. Okay, what's the derivative here? 100 goes to 0. Negative b becomes -1. Okay. I'm cross multiplying and then I'm dividing that -1 over. Dividing by -1 is the same thing as multiplying -1. So I just have db equals -1 du. Okay, make my substitution here. 1 over u du. I'm sorry. -1 du. 100 minus b gets replaced with u. db gets replaced with -1 du. I can pull that -1 in front. Okay, so what's 1 over u du here? What's the rule for 1 over u? Natural log with a negative in front. So negative natural log absolute value of u. Let's bring back the 100 minus b. Okay, so we have the left side complete. Now the right side should be pretty quick. What's the integral of 1? The 1/5 is just coefficient, right? It's really just a 1. What's the integral of 1 dt? It's t, yep. And the 1/5 stays out in front, so 1/5 t and then plus t. Okay, let's get to the general solution first. That way we're not trying to do too much at the same time. So we're just going to try to solve for b before we'll solve for y, right? Yes. Yes, technically they both produce a plus c. We just like to gather them all together and then just have the constant show up just once. That's true, but 2 times c is still a constant, so we just call it just one big c. Okay, so before we will solve for y, but now we're going to solve for b, right? So we just have to keep kind of training our mind to just know that, okay, this b is just a y. We just have to kind of keep that as our process there. Okay, so I'm going to reset here. Okay, I want to get rid of that natural log. So eventually we're going to have to involve what? Base e, but something is kind of getting in the way for us on the left side here. That negative. Because I know e and natural log are going to cancel out, but that negative kind of gets in the way. Is there a way to move that negative so that's not in the way? Yeah, divide or multiply by -1 here. Let's just move that negative to the other side because we don't care if the negative's on this side. We just want e and natural log to be nice and clean so we can actually build that relationship. So I'm just going to just move that negative to the other side. Okay, are we good with that adjustment here? Yeah, but then minus c is the same thing as plus c, since c represents both positive and negative numbers. So we just always do plus c. Okay, now both sides, we can raise both sides with what as a base? B as the base. Okay, left side cleans up, right? Absolute value of 100 minus B. I can separate this. Times what? E to the C. That E to the C is just some coefficient C. We can drop whole in front. All right, so now what can we do with this absolute value?
Good job.
No, that's fine. I'm showing more steps than what you need. So if you're comfortable skipping some steps, that's fine. But as far as this step, though, I do need to see all your use substitution steps here. But I understand if something is, you can potentially skip some steps here because it's the same process over and over again. That's fine. So what can we do here? Absolute value can drop, plus or minus shows up. The C absorbs all that plus or minus. Okay, we're almost there here. Almost all getting that B by itself. I see a negative B here. I'm just going to rearrange it. I'll move the B to the right side and subtract the C. And then that way I have B by itself without having to multiply everything through by -1. So let me do this. 100 minus CE to the -1/5. T equals B. Does everybody see? I mean, you can also multiply everything through by -1 and bring everything over to the right side. But okay, let me reset here. All right, so this is my general solution. I have B by itself. That's kind of my Y variable, kind of my dependent variable by itself. So now I have my order pair that I can use to solve for C, right? So 0, 20, 0 in for what? Okay, but we don't have X anymore. 0 in for T and 20 in for B. I know that's, we're gonna have some more problems where we're kind of getting used to that idea that, okay, it's not X and Y anymore. There's two different variables. But I want to also reassure you that if you see questions that have no X and Y, it's always going to be time and something else. You're never going to have, you at least are going to have this anchor to rely on.
You're always going to be X side, right?
Yeah, that's always going to be on the X side. T is your X, and then whatever strange variable you don't recognize, that's your Y. Okay, so 20 goes in for B, and 0 goes in for T. And we're the whole purpose now is to figure out what C is, so we can update this general equation and make it a specific solution. Okay. All right, what's nice about this term here? Yeah, that's 0, right? And e to the 0 is 1, so that's going to allow me to just solve for C at this stage. I can drop everything to the right of C here. Okay, I'll move the C over to the left side. Subtract the 20. Okay, so now I'm making my substitution. This will replace this. That's my specific solution. It's a long problem, but the nice thing about AP exam, if this shows up on the AP exam for response question, a lot of points are assigned to this portion of the FRQ, and a lot of partial credit are given. And the majority of the points are dedicated to the calculus portion. So if you mess up in the algebraic step, that's probably just going to be 1 point. You know, the majority of the points is, can you separate the variables? Can you take the antiderivative? Can you get that plus c to show up? And then the messiness that comes afterwards, the nice thing is, I mean, it is messy, but it's not worth a lot of points. I mean, you can mess up and still get the majority of the points because you got the calculus right and you have the steps right. So no, just be reassured that it's not all or nothing, right? That's partial credit are given based off of the correct work that you're showing along the way. Okay, let's see if we can make some